Good morning and welcome to Unit 2, Characteristics of Linear Functions Review. In this unit, we are going to be finding the slope given an equation, a graph, or 2 points. We will also be looking at perpendicular and parallel slopes, as well as understanding how to graph a line. The first thing that we are going to look at is the 4 different types of slopes. The first kind of slope that we are going to look at is just as if somebody is walking uphill. So my line will look as follows. This will give us a positive slope. And on the opposite of negative, if it looks like my person is going uphill with a positive slope, my person will be going downhill with a negative slope. Then we dive into the 2 slopes that do become a little tricky. If I have a horizontal line, this tells me that I am only running on my graph, but I'm never rising. Therefore, I am going to have a 0 slope. And last but not least is a line that goes straight up and down. This is where I'm only rising and never running. This is where I'm going to have an undefined slope. So throughout the units and throughout our review, we are going to notice that the same type of equation is going to show up during these. And that equation is y equals mx plus b, where each of these variables represents a different thing. Y represents my output, m is my slope, x is my input, and b is the y-intercept. So I'm going to write the 3 different kinds of equations for these lines. First being with my positive slope, it is going to just be the same exact equation, y equals mx plus b. With my negative slope, the only difference is my slope becomes negative. With a 0 slope, my line is horizontal. Because my line is horizontal, we are just going to look at y equals b. And for an undefined slope, because it is just going up and down, we are going to look at x equals, and I'm going to put a question mark here because we need to look at what number that line is going to cross my x-axis. For a 0 slope, we're looking to determine what number crosses my y-axis. When we look at slope, especially on a graph, there is a phrase that we use. The phrase that we are going to use is called rise over run. And as we continue on through this unit, you're going to notice that the rise over the run becomes delta y over delta x, which is also the same as the change in y over the change in x. So the first slide that we are going to look at is our different kinds of slopes. And again, on the side here I have a note saying finding slope on a graph. We just said that this is going to be my rise over run. So with these kind of graphs, what we're going to look at is I have 2 points here. Not every single graph that we look at will have 2 points on them. There are times where you are going to have to look for them individually. If you notice on these points, there is a perfect intersection on the little boxes in the back. On the one above it, so I'm looking right now right here, it does not perfectly cross that intersection point, so therefore I cannot use it. When we go through these, we are looking to find where these graphs are. We're going to create our slope triangles. So when we read a graph, we always read it from left to right. So when I find my slope, I will look at it as left to right. So when I start off, I will put my pen here. I will go up to about where that line is and go straight across. Now all I am going to do is just count the individual boxes. 1, 2, 3, 4. And because I'm going in the up direction, it's a positive 4. Now I run from here, 1, 2, 3, 4, 5. And because again I'm going in a positive direction, I will have a positive 5. My slope is my rise over run, so for this example, my slope will become 4 over 5. For number 2, I'm going to do the same exact thing that I did with number 1, create my triangle. And I'm just going to count the boxes. 1, 2, 3, 4, 5, 6. So I have a positive 6. 1, 2, 3, and a positive 3. So my slope in this example is 6 over 3. But as we know, we have to fully simplify these down. So my slope becomes 2 over 1, or just 2. Now for number 3, it changes a little bit because now I am looking at a negative slope. I see that it is going downhill. So I will again go from left to right, but this time instead of rising, I'm going to fall, and then I'm going to run to my second point. I am falling 2 because I'm going down 2, it's going to become a negative 2. Then I count 1, 2, 3, 4, 5, 6, and I have a positive 6. So my slope for this example is negative 2 over 6, and we know that we have to fully simplify it, so my final answer would become negative 1/3. For my last graph here, for number 4, I am going to show you a different way in defining it, because of the fact that this is we know this is a negative slope. And I want to show you that there are different ways. You can do it with the positive, you can do it with the negative. You can change the way your thinking is. In number 3, I went down 2 and then I ran in a positive 6 direction. For this one, I am going to go up and then run to the left. So because I'm running to the left, that will give me my negative number. So I have 1, 2, 3, 4, 5, 6, 7. I have a positive 7 here. 1, 2, 3, 4. And I have a negative 4 here. My slope becomes negative 7 over 4. And all I did was take the negative and put it in my numerator here. If I did it the way going from left to right, I would drop 7 and run in a positive 4. It still will give me the same slope. So when you're looking at the slope of a graph, you are always considering your rise over your run. And now what we're going to look at is the individual points. So if I just gave you 2 points on a graph and just said find my slope for me, the formula that we are going to use, and this is a formula that we need to understand and remember, is y2 minus y1 divided by x2 minus x1. And if you remember in class, I did talk about that you can have y1 minus y2 divided by x1 minus x2, as long as you have the first points the exact same. So if you start off with y2, you must start with x2. If you start with y1, you must start with x1. So the first points we have here is negative 13 and 8 and 3 and 12. This means that my 13 is my x1, my 8 is my y1. My 3 is my x2, my 12 is my y2. I am going to use y2 minus y1 divided by x2 minus x1. Doesn't matter what formula you use, you will arrive at the same answer. So I'm going to have 12 minus 8 divided by 3 minus a negative 13. So because I do have 2 negatives, it changes to a positive. 12 minus 8 will give me my 4. And 3 plus 13 gives me 16. 4 over 16 is not my final answer because it can be simplified. I will divide them both by 4 to get a final answer of 1/4. Now for number 2, I have 19, negative 12, and 5, 16. I'm going to show you the y1 minus y2 formula here, where I have negative 12 minus 16 divided by 19 minus 5. Negative 12 minus 16 will give me a negative 28, and 9 minus 15 is 14. I can simplify that down to negative 2 over 1, or just straight up negative 2. Now, when you go through these, there are going to be examples where your numerator will be negative. If you see that your numerator, not negative, is 0. When you see that your numerator is 0, that means you are going to have a 0 slope. So if I have 0 over, and let's just choose a constant k, this means it's a 0 slope. If I have a number over 0, this becomes undefined. It becomes knocked out. So I have an example here where I'm asking individual questions on finding the slope. First question, find the rate of change in the high temperature between June 1st and June 6th. So I'm going to take my 76 minus 72 divided by 6 minus 1, I will get 4 over 5. And so my slope here, or my rate of change, because the rate of change is just another word for slope, becomes 4 over 5. The rate of change in high temperature between June 6th and June 8th, again, I'm going to choose my 2 points, 84 minus 76, divided by 8 minus 2. 84 minus 76 is 8. And 8 minus 2 is going to give me my 6. 8 divided by 6 does simplify itself down to 4/3. And last but not least, it says, during which of these time intervals did the temperature rise the fastest? So we're looking at A and B. 4/3 is my higher number, so from June 6th to June 8th is my highest interval. Parallel lines. Parallel lines are two lines that will never intersect. So I'm going to draw an example of my parallel lines here. With parallel lines, they are going to have the same slope. This is key to know because when you go through or start writing these equations, you need to understand that parallel lines have the same slope. So if in one equation I give you y equals 4x plus 5, and I tell you that I want a parallel line to that equation, I could say y equals 4x and then put minus 5. The y-intercepts here are going to be different, but the slopes remain the same. Perpendicular lines are two lines that are going to intersect to create a 90-degree angle. So when they intersect, this means that they are going to have a negative reciprocal slope. So because they have a negative reciprocal, when I look at my first equation, y equals 4x plus 5 again, we'll use the same equation. My negative reciprocal becomes y equals negative 1 over 4x, and I can put minus 3. Those would become my parallel lines, well, my perpendicular lines, I'm sorry. Parallel lines have the same slope. So I have a few examples now with the graphing. When we graph this, we are going to first use our y-intercept, so a positive 1. I'm going to put a dot. And then I'm going to use my rise over my run to get my second point. 1, 2, 1, 2, 3. And again, that helps me create my triangle, and I create my straight line with my 2 arrows at the end. I'm going to skip numbers 2 and 4 here, but I am going to go to number 3. I am going to have a negative 4. 1, 2, 3, 4. And then I'm going to drop 1, because there's my negative, and run 2. Again, should look as if you are going downhill. Standard form of an equation. Standard form that we look at is in the form ax plus by is equal to c. When we get to these kind of questions, we are going to actually look for our intercepts. We are not going to try and move it around. That will be done at a later time. So for this, for me to find my x-intercept, I am actually going to just cover my y. So I'm going to have negative 2x equal to negative 1. And I'm going to just solve for x. So I'm going to divide by negative 2. X will equal 1/2. And on my on my x-axis, I apologize, I'm going to put a dot at my 1/2. To find my y-intercept, I'm just going to say y is equal to negative 1. And that's pretty easy. I go to negative 1, put a dot, and there is my line. If I wanted to change it where I have it in slope-intercept form, I would say negative 2x plus y is equal to negative 1. I'm going to add my 2x to both sides because I want to isolate that y by itself. So then I'll have 2x minus 1, which would give me the equation to graph just as I did in the previous slide. That is what I have for the characteristics of linear functions. Thank you.